you have a clock, it's ticking at a certain rate. You send it in a spacecraft that's going at some significant fraction of the speed of light. To you as an observer at rest, that clock that's in the spacecraft will seem to be ticking much more slowly. And so, in other words, it's kind of like the twin who goes off to Alpha Centauri and goes very fast will age much less than the twin who's on Earth that is just hanging out where they're hanging out. Mm-hmm. Okay, why does that happen? Okay, so it has to do with what motion is. Mm-hmm. So in our models of physics, what is motion? Well, when you move from somewhere to somewhere, you're having to sort of recreate yourself at a different place in space. Mm-hmm. When you exist at a particular place and you just evolve with time, you're updating yourself, you're following these rules to update what happens. Well, so the question is, when you have a certain amount of computation in you, so to speak, when there's a certain amount, you're computing, the universe is computing at a certain rate, you can either use that computation to work out, sitting still where you are, what's going to happen successively in time, or you can use that computation to recreate yourself as you move around the universe. Mm-hmm. And so time dilation ends up being, it's really cool actually that this is explainable in a way that isn't just imagine the mathematics of relativity. Mm-hmm. But that time dilation is a story of the fact that as you kind of are recreating yourself as you move, you are using up some of your computation. And so you don't have as much computation left over to actually work out what happens progressively with time. Mm. So that means that time is running more slowly for you because it is you're using up your computation. Your clock can't tick as quickly because every tick of the clock is using up some computation, but you already used that computation up on moving at half the speed of light or something. And so that's why time dilation happens.